So we have triangle ABC and triangle XYZ. And we're doing triangle congruence here. All right, so I'm gonna move kind of quickly because I want to make sure that you guys have it with me. So to note that that AB is congruent to XY, we're gonna use one hash. And down here, we're gonna say AB is congruent to XY, okay? And you're gonna do that with this hash mark here. And basically what we're gonna prove is that all the sides are congruent. So for this one, we'll do two hashes here. We'll say something like AC is congruent to XZ. And this right here, the last three, what should that be? What should that statement be for the last set of sides?
BC is congruent to YZ.
Right, BC is congruent to YZ. And this is the sides. These are our sides. Now, angle A then is congruent to angle X. I'm gonna let you guys do the other two angles and then tell me what they are. So what could I say next?
B is congruent to Y.
I'm sorry, what?
B is congruent to Y.
B is congruent to Y. All right, and what next?
C is congruent to Z.
Yep, C is congruent to Z. Now, when I say the triangles are congruent, and we can say that with this, we can say A is congruent to X, we can say B with 2 is congruent to Y, and we can say C with 1, 2, 3 is congruent to Z. 1, 2, 3 hashes. I'm gonna pause right there to make sure that your notes look like my notes. I want to make sure your notes look like my notes. And I am recording this, so Miss James, I'll try to get you that recording immediately after I'm done.
Okay.
So we've got angles, we've got sides are congruent. So these are what we call specifically, and this is how I want you all to say it. These sides are what we call corresponding sides. And these angles are corresponding angles. All corresponding means is that they sit in the same place. All right. So we got corresponding sides, and then we got corresponding angles. We got corresponding sides, corresponding angles. If they corresponding sides, then that means the sides correspond. If they have corresponding angles, that means the angles are the same measurement. Okay. Now, there are 4 congruence postulates, I think. I'm gonna see if I can remember them. But before we even get into that, how would I write that these triangles are congruent? How should I write that the triangles are congruent? How can I write that? Okay, I'll help you out. I can say that triangle A, B, C, so A, then B, then C, is congruent to triangle X, Y, Z. Triangle X, then Y, then Z. Okay? Note that all the information that you need is in this postulate here, or in this statement, this congruent statement. Angle A is in the same place as angle X. You see how those correspond? Hold on, let me use a different color. Angle A corresponds with angle X. We get that right here. Angle B corresponds with angle Y. You get that right here. Angle C corresponds with angle Z. You get that right here. Okay. You can see that AB corresponds with XY. AB corresponds with XY. You can see that BC corresponds with YZ. So BC corresponds with YZ. You can see that AC corresponds with XZ. AC corresponds with XZ. All of these are extremely important to note. And whenever you have a triangle situation, you have to make sure that your corresponding parts are set up in the correct way. All right. Your corresponding parts are set up in the same way. Everybody cool with that? So you should have all of this down on your page in your notebook. I'm about to move on to something else, but in your notebook, all of this should be down. I'm giving you guys a minute to make sure that you got it. I'm going ahead and sending the screenshot over while I'm thinking about it. All right. Now, the next thing we're going to talk about is congruence. Congruence theorems. There are a few of them. And I'm going to go through this very quickly. Okay? The congruence theorem are side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. And there is, but angle, side, side is not a congruence theorem. So SSS stands for side, side, side. Side, angle, side, this stands for obviously side, angle, side. I'm not expecting you to memorize these, okay? But you do need to have them down. Angle, side, angle, 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 side, hypotenuse, leg. Those are your triangle congruence theorems. We're going to talk about what all of those mean in just a second. I'm going to pause right there because I want to make sure you got them all down. Side, side, side is the easiest one. I'm just going to go ahead and create some triangles here. So go ahead and keep writing down all of these if you haven't gotten them yet. But I just want to make sure that I've already got this kind of together. One second. So I'm hoping all of you guys got all of these down now. You can create the triangles as we go, but I just want to go ahead and kind of make them. All right. Side, side, side theorem. Side, side, side is very simple. What you're saying in the side, side, side theorem is that all of your sides, so like say these two sides are congruent to these two sides, and then it's congruent to these two sides. So basically all it says is that all your corresponding sides are congruent. That's literally all side, side, side does. So all it states is that all corresponding sides are congruent. That's it. That's literally all side, side, side means. So what do you all think that side, angle, side means? If I had side, angle, side, what does that mean?
Have an angle in between two sides.
Yes. So basically it's like this. If I know that two of the sides are congruent and I knew these other corresponding sides are congruent and the angle between them is congruent, then I know the two triangles are congruent. Okay. So remember, we can't go off of just angles, right? But we can go off if all the sides are congruent. And we can also go off two of the sides and the angle between the two sides is congruent. So basically what we can say is if two corresponding sides and the angle between, then you're congruent. And notice, it's very important to note that this the angle between them has to be congruent. So that said, what do you think angle side angle is?
If y'all see side, angle, side, is this like the opposite? Angle, side, angle? So what would it be? Maiden, sit up, please, huh? Dansby. Dansby. Okay, stand up. Stand up.
If side angle side has two sides where the angle between them is congruent, then what would angle side angle be?
One side, say it again. One side with two. Okay, what would one side be? What would it be? You see how the side, angle side, and the two corresponding sides, and the angle has to be in between? So you said that angle side angle is two angles and a side. So where would your side be?
That's it. That's it. You have two corresponding angles and the side between them is congruent.
You see what I'm saying? That's what I was asking.
Go ahead and put these diagrams in your notes, guys. You're gonna need all of this.
Yeah, you missed the line.
Like I said, I'm not expecting you to memorize it, because if you have it in your notes and we say, hey, use your notes, you'll be fine.
Stand up.
All right, we got angle, angle, side. This one just says of two corresponding angles and any side, right? Any side, then you have congruence. Okay. So I know that these two triangles are congruent because I know their corresponding angles are congruent, or two of the corresponding angles are congruent, and one of the sides, any of those sides, is congruent. Okay. The last one is hypotenuse leg, which says that if your hypotenuse of the right triangle is congruent and one leg, any leg, is congruent, then they're congruent. So if the hypotenuse and a leg is congruent, then the two triangles are congruent. This is only for, note, this is only for right triangles. This is only for right triangles. Okay. Now, there's one more that people think might be a congruence theorem, and it's called side-side angle, which looks like this, right? You got two sides like that, and then you got an angle. Side-side angle can also be written as angle side-side. These two are the same. But the way I used to tell my students is an ass can't be congruent. Okay? So that's how I remembered it. This is not. You think you should write this down? I think you should. Not a congruence theorem. You have angle, angle, side. You have side, 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 or you have side, angle, side. But angle, side, side, not a congruence theorem. And I misspelled congruence. Good grief. But same rules apply. Not a congruence theorem. No asses or SSA. Either way, it does not work. Can't just have two sides in any angle. Angle has to be between the sides. All right, I'm gonna pause right there because I want to make sure everybody's got all of this. Once again, you don't have to memorize it if you copy it. You know what I mean? You don't have to memorize if you copy. All right, y'all ready to do some problems? We ready to do some problems here? Well, if you are, great. If you're not, well. Let's move on to Delta Math. I'm gonna get you guys started here. And basically, Miss James just want to let you know, even though that activity was good up to like the 9th page or so, I think it was just going to take a little too long, and I really needed to get to this, so that's why I kind of went off of that. Also, I wanted everybody to have notes so they can refer back to them. Okay. So that was just a quick aside. All right, I'm gonna pull up this notability one more time just to make sure that you all have these notes. Where's all the rest of it? Yeah, I was about to say. And I mean, I guess technically y'all could take a screenshot of this as well, or maybe maybe Ms. James will be nice enough to post this, or I might be nice enough to post this into Google Classroom so you can have it. But you need this, you need this. Okay. Both of these are going to be extremely important for you to be able to complete the Delta math that we have for you. Ms. James, how much more time do I have?
20.
Okay, perfect. This is going to take 5. So y'all going to have, you're not going to finish this today, but you are going to at least be able to get started. All right. So go ahead and go into Delta math right now, because I want to make sure that you all know how to do it. All right, use the drop-down menu used below to state the sequence of transformations that map figure P onto figure Q in the animation. And you'll notice that you only have one problem to do. All right, so this just has to kind of like almost a review. We can see that there is a reflection over the y-axis followed by a translation by, it looks like from here to here is, let's see, 1, 2, 3, 4 units to the left. The two figures are congruent because only rigid motions are used to map figure P onto figure Q. Once again, rigid motion just means that no dilation. So it wasn't blown up or, you know, whatever. It's similar if two shapes are dilated, but in this case, no dilation was used, only translations and reflections. Okay. So boom. Hold on. Reflection over the y-axis. Yeah, followed by a translation. Left 4 units. Two figures are congruent because only. Wait, what did I do wrong? Hold on. This reflected. Oh, this is figure P.
P.
Is it figure P? Okay,
Yep.
now I done confused myself.
They got to go there.
I done confused myself now. Hold on.
Two figures are.
This.
You gotta put P onto Q.
Trying to get Q on the P.
No, it says.
I said this is
Just
figure
map
P.
bigger P onto Q.
Okay. Well, I guess they translated to the right 4 units and then reflected over the y-axis. I don't know. Let me double check and see. Oh, okay. All right. So I just had them in the wrong order. I reflected first and then translated. Interesting, but okay, cool. It's only one problem like that though. We can move on. All right, so in this case, if I wanted to translate figure S onto figure T, what I might do is a rotation, you know, of 90 degrees clockwise, followed by a, I don't know, dilation with a scale factor of, it looks like this piece right here is 1, and then this is 3. So maybe a scale factor of 3. I don't know. Let's find out. Oh, that works. Look at that. That they're not congruent because non-rigid motions are used. Non-rigid meaning I used a dilation in this case. They're similar, but they're not congruent. Okay.
Maybe.
Now, that might take you a while. If you want to skip the first 2, that's fine. Okay. But you also, don't forget, have your help and all that stuff that you can do. Watch help videos, show examples and whatnot. Here's where I wanted to get to. This is the most important part. Okay. This is what I want to get to. So the first 2 is more like a warm up. This one, these is where you get into the stuff we talked about. So determine the relationship between the 2 triangles and whether or not they can be proven to be congruent. In this case, we have 2 sides, but specifically, we have 2 hypotenuses and we have a leg of a triangle. So what, according to this, if you wrote it down, which congruence theorem can we use to prove these 2 are congruent? You have 2 hypotenuses. Okay, let me blow it up. You got 2 hypotenuses, you got 2 corresponding legs, and you have a right triangle, so it's congruent. So it's hypotenuse and leg. So the first question I have to you guys is, are these congruent? Yes or no?
No.
What'd you say?
Are they congruent?
Yes.
Some say yes.
Yes, they're congruent. Why? Which theorem can you use to say they're congruent?
SAS.
SAS?
Side angle side, that is just it.
The side angle side doesn't work here because the angle is not between the 2 sides.
So you got 2 angles in between them 2 sides, so it's not side angle side. What is it? HL, someone say yes.
It is HL. It is hypotenuse leg, because this is a right triangle with a hypotenuse and a leg. So we're going to say hypotenuse leg. So the triangles can be proven congruent. Okay. You might not get all of these. That's okay. You're just going to try your best. All right, let's do another one. In this case, do you all think that these 2 are congruent?
Yes.
Yes. Why? Which one can you use here?
Angle side.
I heard something, but I can't hear what you're saying.
SAS.
SAS, that is correct. You have 2 corresponding sides. You have this side corresponds with this side. That's S. You have this angle corresponds with this angle. That's A. And then this side corresponds with this side. So that's S. So S, then A, then S. S, then A, then S. Okay. So we go down here. 2 triangles are related by side angle side, so they can be proven congruent. All right, let's do another one. So in this one, let's see, we've got we've got an angle that's congruent. Okay. Then we have sides that are congruent. And then we have these two other sides that are congruent. Are the two triangles congruent?
Yeah.
Are they congruent?
Yeah.
No, they're not congruent. Why? Look at what we have. Look back at your paper. What is the only one that's not congruent? We can't have a what?
That's the last one on there.
We can't have
And are not congruent.
Yeah.
we can't have an S. We can't do that. That doesn't work. Side angle, side, they don't work. The only way it works is if it's hypotenuse leg. In this case, it's not hypotenuse leg, so it doesn't work. So this is not congruent. No. I mean, they might be congruent, but we can't be for sure that they're congruent because it's angle side. Okay? I think that should be the easiest one to remember.
They want you to, I think a lot of people done got through that one, that section. The flow chart one is where everyone is, that's the talk of the classroom right now.
Okay. All right, cool. That's good. It's good that y'all are able to get through that. All right, determine two triangles are necessarily congruent. Fill in the flow chart. So the two triangles, we can kind of see we got two angles and we got a side. So they are congruent. Type of statement. So what you want to do is you want to start with the things that are given. Okay. Now I'm going to prove side angle. So what I'm going to, or either one. So the type of statement that I want to prove is I want to prove that the sides are congruent. So for this tells me that sides, okay, sides are congruent. Okay, if you see the angles, this one represents angles. So what I want to do is I want to prove that the sides are congruent. Okay, so I'm going to prove the sides are congruent. I'm going to click on this. It's my statement. Sides are congruent. I know that AB is congruent to ON. So I'm going to write that in. AB is congruent to ON. I'm going to do the same thing on the next one. Now I want to prove some angles are congruent. So I go to angles. That's the type of statement I want. I'm going to say that angle A is congruent to angle O. I'm going to prove the other angles are congruent. So I'm going to do angle C is congruent to angle M. And now we've got angle side in this case. So I got two angles, and then the side's not between the two angles. So it's angle side, not angle side angle. Okay? Because the side's not between them. So I could do angle side. Submit.
Okay. One of my students on her computer, it shows her two triangles. Triangle AZB, well, yeah, AZB, and triangle LM and N. But her type of the statement is asking her about X and Y.
You gotta click on it.
She said he said.
You got to click on X and Y. That tells you what type of statement. So like, for example, like if I wanted to do this one, so let me pull up another one. So, oh, these are not. Hold on 1 second. Man, a bunch of these just aren't. Hold on. I'm just trying to get to a problem that gives me Okay, okay, great. So when you see the X, Y, and YZ, all that's saying is what kind of statement do you want to make? So do you want to prove that the sides are the same? Hit this one. Do you want to show that two angles are the same? Hit this one. So let's say I wanted to show that AZ is congruent to KL. I would hit, okay, I want the sides to be the same. Click on that, and then it'll pop this up. You see what I'm saying? So then I can say AZ and KL. Then the type of statement that's what these are. This isn't actually YZ and stuff. This is just saying what kind of statement do you want to make? Do you want to say that the angles are the same? Do you want to say that the sides are the same? So if you see a little sidebar, that means sides are the same. You want to do the little angles, then you want to prove that or show that the angles are congruent. So we got X, Y. I want to do that congruence. I'm gonna say that A is congruent to K, so I can just do A. Okay. Does that make sense? Does that answer your question?
Yes. Just say yes.
The last one I'll do is this last angle. Angle Z is congruent to angle L. And then I've got angle, side, angle. So I'm going to hit angle, side, angle. All right, here you're given your givens. And then we're going to kind of like do some proving. Now, for this one, these are going to be harder, okay? And you're probably going to have to show some examples, all right? But I know that you can do it. I believe in you. This is the last thing I'm going to say, and then I'm done, okay? So, for these, and these are harder, okay? First thing we're told is that AB is congruent to DC, okay? So what I can say is I know that AB, so A to B, this right here, congruent to DC, right here. Okay. This tells me a lot of information that you have to use from stuff you already learned. I can tell a few things from this. First, I can tell that angle C is congruent to angle A. How do I know this? What do we have? How do I know that these two are congruent? Considering that these two are parallel. What angle theorem do you have to know that angle C is congruent to angle A? These are what kind of angles? What kind of angles are these? What kind of angle pair is that? I already got y'all started. Alternate what? Bless you. Alternate what?
Parallel lines, transversals. Come on. What are they? I see it right there on the tip of your tongue. Come on, spit it out.
It's okay if you get it wrong. Just give it a shot.
And start is alternate what?
Exterior.
Did you say exterior or interior?
Exterior.
So exterior means they're on the outside. Interior means they're on the inside. So this is the interior. This is the exterior out here. This is exterior out here. So are they alternate interior or alternate exterior?
Interior.
Thank you very much. Guess what? Angle B is congruent to angle D. How do I know that? How do I know that angle B is congruent to angle D? How do you know that?
B. Both of them,
Hate it.
they're alternate exterior angles.
Are they on the exterior or the interior?
Wait,
They're also alternate interior angles. Because they're still on the interior. They're on the interior between these two.
oh.
Mm-hmm.
No way.
And then angle. I can say the angle CED is congruent to angle AEB. I can say that this angle is congruent to this angle. Because these are what kind of angles? What kind of angle pair is that, guys? Starts with a V.
What kind of angles are those on the inside made it?
Vertical.
Thank you. So remember all this stuff that we've already covered, guys. It came back just like I said it would.
You're too enthusiastic.
Huh?
Nothing.
You
So
said
angle A is congruent to angle C because these are
Skipper.
Yeah.
all right angles congruent. Parallel lines cuts by alternate interior angles. Boom. Then we're gonna say these two are the same. A to E is congruent from C because we're told that E is the midpoint of AC. So if E is the midpoint, right? If E is the midpoint, then we have, think about it like this. What does a midpoint mean? What does it mean to be a midpoint? It's not a trick question.
You got the beginning, you got the end. So what is midpoint? Okay, let's say in the middle.
Right. So that means that this angle has to be the same as this angle, or this side has to be the same as this side. Got to be. Because if it's halfway, then that means you cut it in half. Or segment bisector, we could say. So here we have a segment bisector. Divides the segment into two congruent segments. Easy. Then this one the same way. Okay, they proved it a little differently than I would have, but whatever. So basically what they're saying is that these here are congruent and these here are congruent. Okay. Now we're given that CD is congruent to AB, but there's so many different ways we could have proven this at this point. But we've gotten three. The key to these are you have to keep track of what they say are congruent. So you're told that A and C are congruent, okay? AB. Oops, I'm sorry. Hold on. This one's wrong. Oh, actually, that was given. This one is given because you can see that AB is congruent to CD. So since it was already told to you this, you can say this, okay? All right, so let's walk through all of the reasoning. So we know that the sides are congruent. We know that an angle is congruent. So we got this side and this side. We've got this angle and this angle. What kind of what kind of congruence theorem should I use here? What congruence theorem does that look like? As I've got two sides, two angles, and then two sides. Since you have a side, an angle, and a side. A side, an angle, and a side. What is that?
SAS.
Thank you very much.
Thank you, Raisa.
Not me, Jane. What?
No, I'm saying tell her how to speak up.
I just couldn't
That's
hear
what I-
y'all. Like the headphones that I'm wearing are really bad, so I can't. For some reason, I really have a hard time hearing. And then, oh, I messed up somewhere. Similar bisected divides. Oh, should said midpoint. My bad. Midpoint divides segment into two. So that's it. It might take y'all a while. Look, it might take you a while to get the hang of these. Okay. But these are open book. Okay. They're open book. Look at the things that I sent you all, the stuff we wrote down together. Let me stop recording.